Hello viewers, good morning, good afternoon, good evening, wherever you are. Our last mathematics tutorial video was on an introduction to simultaneous equation using the method of elimination. In this video, we want to do some examples to entrench our understanding of this method. So here on the screen, we have 5 questions. We'll attempt to solve the 5 questions as fast as possible, but in a way that it will be easy for everybody to understand. So our first question is 4x plus y equals 1 and 7x minus y equals minus 12. So as recommended in our first video, if we want to solve this equation, the first thing we do is to name the equation. So we're going to name this equation 1 and then we name this equation 2. So I will rewrite 4x minus plus y rather equals 1 as equation 1 and 7x minus y equals minus 12 as equation 2. I hope we still remember our naming convention. All right, having named this equation, I want to solve this system of simultaneous equation with the method of elimination. That means I am going to try to eliminate one variable. And if I'm going to eliminate one variable, just looking at the two equations, all I need to do is to add the two equations, because I know that if I add equation 1 and equation 2, plus y and minus y will go away. I hope we can remember that from our first video. Please, if you have not watched that first video, go to my page, go to my channel to watch that video. It will help you to gain a better understanding. Please comment, share these videos as we watch. So just like we said, our first operation will be equation 1 plus equation 2. And if we add equation 1 and equation 2, 4x plus 7x will give us 11x plus x plus y minus y will go away. 1 minus 12. We're just adding the two equations. 1 minus 12 is minus 11. So just as you can see, x has a coefficient. In this case, we have successfully eliminated the y variable. Now the x variable that is remaining has a coefficient. All we need to do is to divide through by the coefficient of x, which is 11. So we'll now say 11x all over 11 is equals minus 11 all over 11. And if we do that, 11 here will go with 11. And also, if minus 11 and 11 can also cancel out. So on the left hand side, what we have left is x, and on the right hand side, what we have left is minus 1. So we have gotten our first answer. X equals minus 1. And what do we do at this stage? We now go ahead to substitute x equals minus 1 into one of the original equations. So just watch. So I'm going to choose equation 1, which says that 4x plus y equals 1. So if we substitute x equals minus 1, that means 4 times minus 1 plus y equals 1. I'm going to move. Okay, 4 times minus 1 is minus 4 plus y equals 1. So at this junction, I want to move minus 4 to the other side. So I will now have that y is equals 1. And when I move minus 4 to the other side, it becomes plus 4. So y is equals 1 plus 4. And that gives us y is equals 5. we have got our value for y. But we don't have to stop here. Let us confirm if these two answers we got satisfy the original equation. So we will take the two original equations, 4x plus y, anywhere 4x plus y equals 1. That means anywhere we see x, we plug in -1, and anywhere we see y, we plug in 5. So 4 times -1 plus 5, does that give us 1? That's the question that we want to answer. So 4 times -1, that is -4 plus 5. Of course, -4 plus 5 gives us 1, because -4 plus 5 is 1, which equals 1. Hooray! So the two values we got satisfied this first equation. But do the two values also satisfy the second equation? Because in a simultaneous equation, the answers you get must satisfy the two equations. Now the second one is 7x minus y equals -12. Where I see x, I put -1. 7 times -1 minus our y is 5. Does that give me -12? All right. So 7 times -1 is -7 minus 5. And -7 minus 5 is -12. So on the left-hand side is -12. On the right-hand side is -12. Hooray! Our answers are very correct, because we have gotten the answers of the variables x equals -1, y is equals 5, that satisfy the two original equations. It's as simple as ABC. Now this is our second question. Let's attempt to work it out. The solution to the second question. First, we start by naming our equation. So we'll say that x plus 3y equals 6. The first equation, we'll name it as equation 1. And then x minus y equals 2. We want to name this as equation 2. And if we do that, we want to eliminate one of the variables. Now, guys, take a look. It is not every time that you have to eliminate the y variable first. Your goal is to eliminate one of the variables, leaving just one. So it depends on the nature of the problem that you are solving. That will determine which of the variables you want to eliminate first. I have looked at these two questions and I have seen that it is easier for me to eliminate the x variable first. I could actually eliminate the y variable first, but it is much easier for me to eliminate the x variable first. So that is what I am going to try to do. And to do that, here I have 1x. In equation 1, I have 1x. In equation 2, I have. So, and it is not every time you add, you do addition to arrive at your goal of eliminating one variable. Sometimes you have to subtract. Sometimes you add, sometimes you subtract. So in this case, I know that if I subtract this equation from this equation, if I subtract equation 2 from equation 1, the x variable would have been eliminated. Can you see that, guys? Yes, that's exactly what we are going to do. Okay, guys, I don't know where the recording stopped, but I'll just walk through these steps. So the first thing that we did was we named these same equations as equation 1 and equation 2. And then what we now did next was looking at equation 1 and equation 2, we saw that if we subtract equation 2 from equation 1, meaning equation 1 minus equation 2, one of the variables will go away because this is 1x and this is 1x. So what we need to do at that point is to say, okay, you introduce minus to every term of the second equation, which we did. I don't know where the recording stops, so that's why I'm going over all of this again. We have to introduce a minus to every step of the terms in equation 2. And when we did that, we can now go, this is the operation that we're performing, equation 1 minus equation 2. So when we did that, x minus x just goes away. Then you now have 3y minus y. So that becomes 3y plus y, which gives us 4y. And then you now have 6 minus 2, which gives us 4. Y now has a coefficient. This new simple equation we got has a coefficient, which is 4. That is why we divided through by 4, divided both sides by 4, and then we cancel out, and then we got y to be equals 1. Now, the next thing, like Ujiro said, is we have to substitute y equals 1 into one of the original equations. We saw that equation 2 was simpler, so we choose equation 2. X minus y equals 2. Whenever we see y, we plug in 1. So we moved y over to this other side. X is equals 2. Instead of minus y, it now becomes plus y. And we know that y is 1. So 2 plus 1. So x, that gave us x to be equals 3. So now that we have the value of the two equations, we want to go ahead and verify to see if these two values satisfy the two original equations. So guys, for the first equation, x plus 3y equals 6, x equals 3, y is equals 1. Let's see how it goes. X plus 3y equals 6. We're saying that wherever we see x, we put 3. So that's 3 plus 3 times y. What is y? It is 1. Does that give us 6? So this is 3 plus 3. Hooray! 3 plus 3 equals 6. So our first equation was satisfied by the value of these two variables. Now we go over to our second equation. Our second equation was x minus y equals 2. Whenever we see x, we plug in 3. So 3 minus our y is 1. Does that give us 2? Of course, 3 minus 1 is 2, which equals 2. So our second equation is also satisfied by these two variables. X equals 3, y is equals 1. So we are done with question number 2. So this is question number 3 that was displayed earlier. 3x plus 7y equals 34 and 3x minus y equals 2. Again, the first thing we do is to number the equations. For solution, we'll start by numbering the equation. Let 3x plus 7y equals 34 be our equation 1. And then 3x minus y equals 2 be our equation 2. Our goal is to eliminate one of the variables. And if we want to do that, one trick is that variable that has the same coefficients in the two equations should be the first variable you want to eliminate. That will make your work easier. So looking at this case, it is x that we want to eliminate. And to be able to eliminate x, because I have 3x and 3x here, To be able to eliminate x, what I'm going to do is that I am going to subtract equation 2 from equation 1. Just look at it. Equation 1 minus equation 2. That is the operation that we want to perform now. So I will subtract this entire equation from this one. That is why I said equation 1 minus equation 2. Meaning I am going to introduce minus to all the terms of equation 2. Did you get that from the last question? So that's exactly what we are going to do now. If we say 3x minus 3x, both of them will go. And then we're now having plus 7y minus y. Minus is plus. So this becomes 7y plus y, which is 8y. And this is 34 minus 2. So 34 minus 2 gives us 32. Now I will divide through by the coefficient of y, which is 8. So I will divide this side by 8. I will divide this side also by 8. And if I do that, what will happen? This 8 will cancel out this 8. And then when 8 divides 32, what we have there is 4. 32 divided by 8 is 4. So on the left-hand side of the equation, we now have that y, only y is remaining on the left-hand side, and on the right-hand side, what is remaining there is 4. So we have gotten our value of y. And if we get a value of y, the next thing we want to do is to substitute this value of y equals 4 into any of the original equation. I'm looking at the two equations. I'm saying that original equation 2 is easier. So I am going to substitute y equals 4 into our original equation 2. So I'm going to do the substitution directly. Look at it. 3 times x minus y (3) x minus y equals 2. 3x equals 2. When the y moves over to the other side, it becomes a plus. And we have been given the value of y to be 4. So 3x is equals 2 plus 4. Instead of 2 plus y, it becomes 2 plus 4. For space, I will just continue doing the work here. So we now have that 3x equals 6. And then we divide through by the coefficient of x there, which is 3. And you have to divide both sides by that coefficient of x. So our x here, or rather, I'll change the pen. Our x, which is remaining on this side, equals 6 divided by 3 is 2. Guys, I hope we're following. Hooray! We have gotten our value of x to be equals 2 and our value of y to be equals 4. But not to hurry yet. We want to see if these two values satisfy these two original equations. So that's the next thing we want to do. Just hang on. So at this point, we want to check. Do these values for y and x satisfy these two original equations? So let's see how that goes. The first equation is 3x plus 7y, we said is equals 34. Wherever we see x, we put 2. That is 3 times 2 plus 7 times y is 4. Does that give us 34? It's a question we're asking ourselves. So that's why I put a question mark there. All right, so 3 times 2 is 6. 7 times 4 is 28. And what is 6 plus 28? Hooray, that's 34. So 34 equals 34. These two variables satisfy this first equation because 34 equals 34. Remember what I said in the introductory video to simultaneous equations or equations generally. Equation is like a scale. The two things on both sides of the scale must balance out each other. Their weights must balance out each other. You cannot have 35 on one side and 32 on the other side. That scale is not balanced. The two loads must be of equal weight. So for an equation to be satisfied, for this equality sign to be satisfied, what is on the left-hand side must equal the right-hand side. Now that we have satisfied the first equation, we'll move over to the second equation, which is 3x minus y equals 2. We plug in these same values. 3 times 2, our x is 2, minus our y is 4. Does that give us 2? Is a question we're asking ourselves. The equality sign must be satisfied. If it is not satisfied, then our answers were not correct in the first case. So 3 times 2 is 6 minus 4. Hooray! 6 minus 4 is 2 and equals 2. So the equality sign is satisfied in both cases, meaning these two variables, y equals 4, x equals 2, satisfy these original two equations, making them simultaneous equation. And this is the value of the variables for the simultaneous equation. I wanted to continue solving the other two, but I will have to now split it into another video. This video is getting too long, but please comment on this video, share this video. I am trying to make these concepts in mathematics as simple as possible. Guys, am I really making them simple? Please give me your feedback. Tell me where you're watching from. Share this video, follow my page. That encourages me to continue doing more. So I'm going to answer the next questions, the remaining two questions, but it is going to be in another video.